Greetings. Here we are at section 9.4 on tangent. Yesterday sine cosine, today tangent. I'm using the same template, so hopefully you have this handy. And a straight edge would be nice also. Now in order to fit this on my screen, my circle is looking a little out of whack, so beware of that, but that's the best I can do for this right now. Um, so there is a point on your paper that I've put on and labeled P. So I think what you need to do to start is let's actually make a ray that goes through that point. I don't like my ray. I'm going to start again. Hold on a minute here. Okay, so you want to start at the origin and draw a ray that goes through that point. Mine's not going to be perfect, but it'll get the point across. And I want to tell you that if you do that, hopefully it will be approximately 38 degrees. This is something I've measured. I'm just trying to prevent us from having to use a protractor. So let's start and review what we learned yesterday, and that was that on the unit circle, the x and y value are not just any old x and y value. Since the location on the unit circle is where the terminal side crosses. Okay, so just to recall, like every single one of these guys starts with an initial side in standard form on the x-axis, and then the terminal side is the side wherever the particular angle ends. So for the 38 degrees it ends here. So this point where that terminal side crosses, it is a fact, is going to be the cosine of the angle is the x value, and the sine of the angle is the y value. And that comes in handy, and it's a good connection to understand as far as sort of the geometric connection. So this one I kind of conveniently selected because it's pretty easy to maybe count and see what the cos and the sine are. So if I count, knowing that my radius is 1, it's the unit circle, so I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So it appears then that the cos of 38 should be approximately 0.8. And then if I count up, I go up 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. And so the sine of 38 appears to be approximately 0.6. Now just for kicks, I'm going to bring up my calculator to see how close that is. So the cosine of 38 is 0.7880. So obviously, I mean, this is just a piece of graph paper, so if we rounded, it would be 0.8. And if I put the sine in, put in the sine of 38 and hit enter, I get 0.61. And once again, if I were to round to tenths, I would get to 0.6. Okay, so let us think a little bit more. And some of you in last night's IXL or MathXL for schools, I couldn't find one that didn't have tangent, so some of you may have already discovered this, but I'm going to discuss it again anyway. When we look at this triangle, so I'm going to create a triangle here by just dropping this line perpendicular. It's not going to be perfect, but you can at least visualize it. And if we go back again and we review, and here's my angle theta, our SO, CA, TOA, or however you want to think about it, when we get to tangent, TOA, tangent is equal to the opposite over the adjacent. So if you think about it really, when I'm looking at this unit circle, I can figure out the tangent of theta by just figuring out what my opposite is, which is this particular line right here, which if you remember is my y value, which in reality is just my sine of theta. And then I can divide that by my adjacent. Once again, this is my hypotenuse. This is my opposite, so this is my adjacent. And so in this case, my adjacent is represented here. And the adjacent really is my x value, but my x value really is my cosine. So some of you may have discovered this last night or yesterday when you were doing the work on the homework on the online, because they sort of lead you to this. So then, in the end then, for this particular situation, the tangent of 38 should really just be equal to the sine of 38, which is 0.6 on my graph, divided by 0.8. And that is equal to 0.75, I guess. But once again, if I go back to my calculator and I hit tangent and I put 38 in, my actual value is 0.78. So if you recall, here we're just working on a grid. Okay, so what's important here? I say, especially down the road a little bit, this is going to be important to have this understanding. So that's a good thing to kind of get a grip on. I do need to just introduce you to one other thing. And it's going to be a bunch of words, and it might sound a little crazy, but this is really the geometric connection, like finding a point on this graph that will actually give me the tangent. Because if you recall, right now, we have the ability, like say our calculator broke and we had a unit circle. If I have a protractor and I know this is 38 degrees right here, and I do a nice job drawing my unit circle and I draw my 38 degrees, I can tell you the cosine and the sine. It will be an approximation, it won't be perfect, by actually figuring out what that x and y value is. So this is like a complete link to geometry here, this trigonometry. So there is actually a link to the tangent value where I can point to a point on this graph. So I'm going to read some wild and crazy words, and then I'm going to try to get you to see what they mean. So it says here, let T be the point where the terminal side, so remember, our initial side is always that sort of positive x-axis side, and the terminal side is wherever this angle goes. So we're, looking at this 38 degrees, so that right there is my terminal side. Of an angle in standard position, this is what makes it standard position, intersects the line tangent to the circle, at a point R10. The tangent of theta is the y-coordinate of t. Okay, so right off the bat that might seem like, what in heaven's name? So let me at least start by labeling R. So for this particular situation, R is going to be this point right here, because that has an x value of 1 and a y value of 0. So just to come back to this again then, it says let T be the point where the terminal side of an angle, standard position, intersects the line tangent to the circle at R10. So tangent to the circle, and hopefully this comes back a little bit from maybe what you learned last year in geometry, is a line which only touches, and I'm going to just draw it right from this point, which only touches the circle at this one point. Now in reality, oops, having a little trouble here. In reality, this should be a vertical line in this case. I'm not sure why I'm having this trouble here. Try it again. Maybe I'll try it from down here a little lower. So I'm going to just go ahead and draw this line that's, oops, tangent. Okay? So once again, in this particular instance then, the point of tangency, as in this line, is just touching the circle in that one point, and it's a vertical line. So according to this mumbo jumbo here, let T be the point where the terminal side of an angle, standard position, intersects the line tangent to the circle at R10. The tangent of theta is the y-coordinate of T. So T then is this point right here. Because what I've done is I've got my tangent to the circle, and then I also have my terminal side, which is extended out, and that point right there, the y value should be my tangent. So now, the x value has to be 1, because that's where I started out here. So my x value is 1, and my y value, based on the mumbo jumbo down there, should be my tangent of theta. So if we look here and we just sort of approximate, and once again, this is me on a smartboard on a graph that I've scanned, nothing about it is perfect. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. If I was reading it, I'd probably read that to be maybe about 0.76 off this graph. Now, when I did my calculation with this division, I got 0.75. when I read it using the point, I end up with a 0.1 comma 0.76. Now, if you remember from our calculator, our tangent value is actually 0.78. So once again, we're using a graph. It's an approximation. It's not perfect, but this is actually a geometric connection that you need to be aware of. I have seen it on a Regents exam. Okay, so just quick review, and then I'm going to do one problem with you here, and we'll call it a video. Okay, so if we draw this famous thing called the unit circle, remember the unit circle has a radius of 1, and we throw an angle in standard position on the unit circle, and we take that terminal side and we figure out where it crosses the unit circle. It is an absolute fact that the x value is the cos of theta, the y value is the sine of theta, and if now we do this extension and then we actually get this tangent line going, it is a fact that this point of intersection, that y value, is the tangent. Now notice, when I talk about the tangent of the angle, that's a different tangent really than I'm talking about when I'm talking about this relationship of a line being tangent at one point to a circle. So just be a little bit careful with that. Okay, so this is an extension which you've already kind of seen from yesterday, but I'm just going to go ahead and do it. So if someone gives you a point on a unit circle and they say, hey, find the sine theta, cos theta, tan theta, you say, no problem, I can do that. So just remember, and notice this coming at you in a different order. Oftentimes we think of sine and then cosine, but remember, the cos is the x and the sine is the y. C comes before s, x comes before y. So the sine of theta is negative 1/3. The cosine of theta is negative 2 radical 2 over 3. And now what we have learned is that the tangent of theta is really just the sine of theta divided by the cos of theta, because tangent is opposite over adjacent, and then opposite in the unit circle is going to be that y value, and adjacent in the unit circle is going to be the x value. Now this one's a little yuckier maybe, because the sine of theta is negative 1/3 all over the cosine of theta is negative 2 radical 2 over 3. So yeah, I'm going to do some kind of scary fraction stuff here. When I have a negative divided by a negative, I get a positive, so I know that's going to be positive. So basically, I'm just going to keep my numerator, and I'm going to change from division to multiplication, and I am going to flip my denominator. So I now have 1 over 2 radical 2, but I'm going to clear that radical 2 out of my denominator, rationalizing the denominator. So now I have radical 2 all over 2 times 2, which would be radical 2 over 4. Okay, that is all I have to say in this video. You will notice that your template on the back there is more information that I'm going to discuss in class tomorrow. So you should now go head on over to that mathexcelforschools.com and try the online homework.